Hello everybody, welcome. Today we're finally going to be in the editor. If you missed last club meeting, we decided that we would have two concurrent tutorial series, one by me and one by Logan, where I'm teaching you about 2D and Logan's teaching you about 3D, where we both go through different projects or different steps on making a project over the coming weeks and show you like all the different mechanics and stuff that we would add and build up a project over time that you can mimic and learn for making your own projects. So today we're going to start off with getting some assets into the game that we can use, and we're also going to get our character to move around screen, the basics of our character controller that we'll kind of build on next time. So first thing we're going to want to do is get these assets. I'll provide you a link to them from itch.io. These are not my assets. These are made by someone else for public use under CC0. If you have no idea what any of that means, all good. Just know that you can use these files in your projects scot-free. So just go ahead and open this and take the warped files and put them in here. Oh, and by the way, I will have a link to where you can find these assets, like I said, and more assets like them on itch.io. Very good place if you are a programmer and don't really have a lot of art assets, or you just want to get something quickly. Itch.io, great place to go for finding assets. And then after you just drag them into your assets window here, I like to make a new folder and just call this external. And that way I can put everything that's not mine inside external, and I know where it is. So I'm going to open that, open this, and then go to the sprite sheets and then the player. Alright, so if you have never seen this before, these are what's called sprite sheets, where you have multiple images or sprites inside one kind of overall image. So for this player idle, right, you can see it has a couple different frames of the animation that we're going to play. And this is kind of how you get movement with 2D sprites, or kind of not just having them look so still and bland, is by animating them, and you just give them different keyframes. So like maybe shoulders up and then shoulders down and then shoulders up, shoulders down, that kind of thing, since this is an idle animation. So we're not going to go over animating in this episode, but we are going to need some graphics to represent our player, which means that we need to get a sprite out of the sprite sheet. So whenever you're importing a sprite and it's in a sprite sheet like this, the first thing you need to do is change the mode to multiple, so Unity knows that there are multiple sprites inside of here that we can select and extract. For your pixels per unit, this entire pack, I believe, is 32. They didn't specifically say on the website, but just eyeballing it, it seems that way. This is nothing you can't get around with scale, and it's also something that you can just change later. So if you don't know what it is for your specific project when you're doing something, that's fine. Just take your best guess at it, and if worst case scenario, you can just change the scale a little bit. The next thing you need to do is change the filter mode to point, no filter. You want to always use this when you're working with pixel art, because the other filters are for blending colors together, which is better for 3D models, but not nearly as good for pixel art, which has like clearly defined spaces for colors to be. If you're curious about more info on that, come talk to me during a club meeting. I'll be happy to go over it a little bit more. And the other thing is change the compression from normal quality to none, so there's no artifacting or anything like that on our sprites. And then hit apply. And now we can go into the sprite editor, and you'll see it'll pull up closer up of the image with all the different sprites on there. And what we're going to do in this screen is just kind of separate these for Unity to know what the bounds of each of them are. So if you come up here to slice, by default it's going to be automatic. You can also do grid by cell size, which Unity will make cells like this, and you can just select like if this one was like perfectly in this cell, This would work kind of good, but it's not. You can change the size or whatever, but we don't need to do that for here. We'll just do automatic and then hit slice. I would note that you can also just draw these boxes by hand. You can delete them just by hitting the delete button on your keyboard. But automatic generally does a pretty good job of getting all of them right on the borders. I would tend to trust automatic, but always review it just to make sure. So this looks good, so I'm going to go ahead and hit apply, and then I'll close this window. And now if you come back to player idle and expand it, you'll see that we have all of the different sprites for the animation inside of here, which is great. We'll have to do that for all of these eventually when we start animating the character, but for now, we don't really have to worry about that. So in the hierarchy here, I'm going to right-click and create an empty and call it not semicolon, player. There we go. And reset the transform. And under this, I'm going to drag in just any sprite from our idle animation and child it under this player. And then I'm going to call this child that we just drag under here our graphics, or GFX, which I just like to abbreviate. And now the reason that we didn't just drag this into the scene like this and have this be our player and whatnot, delete that, is that Unity physics and animation tend not to go well together. So what I typically like doing is having a graphics that has like the sprite and the sprite renderer on here, and then this will have like animation stuff eventually, things that are relevant to just the sprite on this object, and then things like physics that move the player and like handle other things like maybe stats or like movement controls or something like that, just on this object at the top, just to avoid any kind of like conflicts between usually animation and physics. And now you'll see if we come over here to the player, I'm just going to select the move tool and then drag this over here. Yeah, so we have our nice graphics here, and just when we're moving player around in the hierarchy, it's also moving the child. That's what it means when an object is a child of another object. So this graphics is going to follow around the player. Okay. So we need to add a couple components to our player character here. So first of all, we need to add a rigid body 2D. Do not click on the normal rigid body, that is for 3D games. We're making a 2D game here. So the only thing we need to change on this is freeze rotation on the Z. Because if you come over here to rotation and you just put your cursor right here on the Z, you can hold left click and drag it around to kind of get this effect that I'm doing. And you can see that like it's tilting forward and back, and we don't really want that when we're moving. We don't want to just fall over. We want to move just left and right. So make sure to freeze rotation there. And then we're also going to need a collider. So we'll add a capsule collider 2D. And then we're going to click on these 3 dots right here to resize it. So you'll now see we have these anchor points on this, and we can drag them out and just kind of get them enough to cover the most of the player. Doesn't have to be exact or anything. This is good enough, and just click that again to set that. And the reason we use a capsule collider here instead of, you might have been thinking like maybe a box collider, capsule colliders work better with player characters for if we ever have like a sloped terrain. Box colliders don't really move up that very well, whereas the rounded edges of the capsule collider tend to work a lot better. And especially for this shape of character, a capsule collider works really well. The next thing we're going to do is under our assets. I just clicked back to the root folder up here, the assets, and I'm going to create a new folder and call this folder, and let's call this scripts. And then inside of here, we're going to make our first script. So right click, create, and C# script. And I'm going to call this character controller. So this will move our player. Wait for Unity to finish that. And then open this up in Visual Studio. Okay, and then once Visual Studio opens up, you'll see a screen kind of like this. This is just the default template for Unity scripting. So I'm going to remove these comments first thing because I don't really need them by just triple clicking and then hit backspace. And now you'll see we have these two functions here, start and void. Start will be called before update is called, the first frame before update, and update is called every frame that the game is running. And that's just two built-in functions to Unity that have those kind of reserved functions. So first things first, we're going to make a couple variables. So I'm going to make a public float acceleration, and I'm going to set this equal to 400f because I found that pretty good in my testing. If you've never written numbers like this, you just put the f after typing a number like this just to indicate to the system that it is a float value, because this could be interpreted as an integer. It won't necessarily error at you, but it's good practice to do that. And then next we're going to make a public float called max speed, and I'm going to set this equal to 5f, which I found to be pretty good from testing. And then next we'll need to make a couple private variables, so we'll need a private rigid body, and I'll call this RB, and a private sprite renderer called sprite, because we'll need a reference to the rigid body and the sprite on our player. So in start we can get our rigid body on the player by saying RB equals get component rigid body 2D. Oh, whoops, I forgot to type 2D up here. Do not make that same mistake. And semicolon, there we go. And that's going to get us the rigid body that's on our player. And then next we'll set sprite equal to get component in children, because remember the sprite renderer was actually on a different object than what we're going to put this script on. It was one layer under in that child graphics game object. So I'm going to type sprite renderer. There we go. Semicolon. Okay. And now we have a reference to our rigid body, and we have a reference to our sprite renderer. Next thing I'm going to do is change our update to a fixed update. This is called at a fixed interval, whereas update is just called randomly. So if we're running at 10 FPS, it's going to be called 10 times. If we're running at 10,000 FPS, it's going to be called 10,000 times. Whereas fixed update is called on a fixed interval of the frame rate. All that really means, and all you really got to take away from that, is that it's better and more consistent to do physics calculations like movement inside of a fixed update than a normal update. And then just to keep this function kind of clean, I'm going to write all of the code that we're going to be doing in two separate functions called move and flip sprite. And it's going to error at first because we haven't written them yet, but that's fine. So let's go ahead and start by writing the move function. Whoops, Visual Studio likes to autocomplete that. Private void. Do not do animator move. There we go. And then in here, we're going to set, we're going to make a vector2 variable called movement and set that equal to a new vector2 where we ask the input manager to get us a specific axis. In this case, it'll be horizontal for our X movement, and input dot get axis vertical for the movement on the Y. So what this is doing is Unity has a preset defined axis called horizontal and one called vertical, and by default those are bound to WASD, where A and D are left and right, and W and S are vertical. And so we're going to get that from the input manager for whatever button we're pressing, and it's going to put that inside of this movement vector 2. A vector 2, by the way, all that it is a x and y. And if you think of like a graph in kind of geometry or math, where you have your positive y, positive x, and negative x, that's really all this is, and it's just a way to store that information. The first thing we're going to do with it is we're going to run a quick check and make sure that the movement kind of stops where we want it to. So we're going to write if movement equals vector2.0, which means that we are not pressing any buttons on our keyboard. If our movement is 0 here, no buttons are being pressed. And if that's the case, we want to set our rigid body dot velocity, which is the speed that the rigid body is moving at, equal to vector2.0. So this velocity has a certain speed that's moving on the x and y, but if we have stopped pressing any buttons, we're going to set that to 0, because in my case, I want the player to stop immediately when I stop pressing the button. Okay, and now we're going to actually add our force to the rigid body, and we're going to give it the movement variable that we made times our acceleration times time dot delta time. And the reason we do this is because a vector, in terms of, again, math, which is just kind of a line, and we want to increase that line and like how fast it's moving, essentially, by our acceleration. So acceleration is telling it how fast we are wanting to speed up, essentially. And the reason we multiply this by time.delta time is delta time is the time in between frames. And that should be pretty consistent regardless of the frame rate. And by doing that, we get a more consistent physics calculation, and yeah, I mean, we just get a more consistent physics calculation, which is what we want. So next, we want to tell it the type of force that we want to apply by passing in a force mode 2D. This is an enum, which has two different values that it can be, either force or impulse. And in my case, I want to do force because I want it to kind of slowly speed up. You can experiment with impulse and see if that's more like what you want, but in my case, I want force. And then we're going to do one last check to make sure that we do not exceed our max speed, because right now, if we just left this alone, it would just continue accelerating as long as you press the button forever and ever and ever, which is not the greatest. So we want to basically cap our magnitude of the vector, or of our velocity, sorry. Well, velocity is a vector, and we want to cap the magnitude of that vector. And what that means is, so you know a vector is typically like a line with an arrow on it, and that's some length, and the magnitude is the length of that line. Well, when we're accelerating, the magnitude is slowly growing, and we want to say if our magnitude is greater than what we have set our max speed at, then we want to just cap it at whatever our max speed is. We don't want it to go any higher than that. So we're going to say RB dot velocity equals RB dot velocity dot normalized times max speed. And now this is how you set it equal to the, this is basically how you set your velocity equal to your max velocity here. The reason that you normalize it is a little complicated. Explaining normalization gets a little difficult in the confines of just this video. Just trust me that this is what you need for now. If you're curious about it, you can ask me during club time, and I'd be happy to give you a more in-depth explanation. But for now, this is actually everything we need inside of our move function. So we're done here. And I'm going to make another function for the flip sprite. Oh, whoops, I forgot to put void. There we go. And you'll notice in the editor here, if you go to the player graphics, there's this flip setting for the X and the Y. And by default, our sprite is facing to the right over here, which is fine if we're moving to the right. But if we suddenly start moving to the left, well, that becomes a bit of an issue when we're looking right. And so we're going to manipulate through code this flip X value here so that whenever we're looking left, this sprite is flipped, and whenever we're looking right, it's not flipped. So going back in here, we're going to check if our rb.velocity on the X is greater than 0. And the reason for this, the reason why we're checking this is that if our velocity on the X, which is moving left and right, is greater than 0, well, if you picture the graph that I was describing, where you have the positive negative X, positive negative Y, positive X is moving in the right direction, and negative X is moving in the left direction. So if our velocity on the X is greater than 0, that means that we're moving right. And so we want to set our sprite.flipX to false, because our sprite is already looking right. And then here, we're going to do another check, and we'll say if the velocity.x is less than 0, then we want to call sprite.flipX equals true. And I believe that is everything that we need to start testing this. Great. So I'm going to save that with Control S, or you can come up here to File and then click Save Assets. Save, or whatever the file path is there. And then minimize that. And let's go ahead and drag this script that we made onto our player game object. Again, the top level one called player. And, oh, where is our graphics offset? Did I? I accidentally moved the graphics. That is what you definitely do not want to do. If you ever move this without moving the player, it's going to offset its position relative to this parent game object, which is what you don't want to do. You always want to be moving the player game object, which is a rule I already broke. Don't be like me. Anyway, if that does happen, just set the position inside of the GFX to 0, like I did there. But really quickly, I actually forgot, we do need ground to test this on. So just super quick, I'm going to come over here in the hierarchy to create 2D object sprites, and I'm just going to make a square and call this ground. And I'm going to change the color to just like a more blackish color and move it under our player a little bit and up the scale on the X just so it's a little longer, we can walk on it. And then give this a box collider 2D, which will automatically fit to the size of the sprite, which is great. And now let's hit play and see if we have some movement. Yep, as you can see, our sprite rotates correctly. We accelerate up to a certain speed, but we don't exceed it. Yep, this is looking pretty good. All right. So if you're interested in playing around with these settings some more, feel free to. Just note that your max speed needs to be a pretty low number compared to what this acceleration is, just because of how physics and vectors work and all. The magnitude is, or the max speed, sorry, is going to be roughly, well, I'll just explain it like this. So let's say that, like, you would assume that if your acceleration was 400, you would want your max speed to be 500, but that's not actually the way that magnitudes work. So instead, you just take kind of whatever number you're thinking about, if you're thinking in terms of that, and divide it by 100. So in this case, it'll be 5 instead of 500. You could change this to 10, which would be 1,000, or 9 at 900, something like that, and kind of experiment with where you want your max speed to be. You can also change this acceleration, make it slower, make it faster. But that's why we have these public, is so you can change them in the editor like this, which is very nice. And again, like I said, you can also experiment with the impulse force mode, and you can experiment with like removing this instant stopping if you don't want that for your game. But that is pretty much it for this tutorial. Next time, I don't know what we're gonna do yet. Probably add some more controls to this and maybe get some animations going. But I'll leave that up to future me to decide. Thank you so much for watching the video all the way to the end. I really appreciate it. And if you had any questions about it, feel free to either leave them in the comments or come ask during club. We have a specific designated time for people to ask questions about these tutorial videos. So make sure that you're coming to the club meetings. But other than that, again, thanks for watching, and I'll see you in the next one.